before doing lab number 4, you have to prepare 4 files in the same folder. You have to copy it, you have to create and save it, no matter, just you have to prepare 4 files, so models in the same folder. And so 3 files are from the lab number 3, and the fourth file is the simple shaft. Just the diameter should be 50 millimeters, and the height is 300 millimeters. So you can create this kind of cylinder as a part 4. So after copying, after making 4 files, and after putting together everything in the same folder, you can start to create a assembly. You can create your lab number 4. So you have to open the SolidWorks and create new file, and here instead of part we have to select the assembly to arrange every part together all together, and click OK. So you will have this in the left hand side of the screen. You will have begin assembly GUI, and if you not, you can simply click you can open those things by clicking insert components, CMSync, and you have to click browse button, and you can open that folder what you combine everything there. So G3 lab 3, so those are 4 files, and you can see here what files are there, and select which part, the first part to insert to your assembly. So in our case is this part is the base part, and click open. So you can see this kind of part is trying to set on your assembly, and also you can see here X, Y, Z, so and then with degrees. So what's the meaning of this? So if you set your part in proper position, so to make this properly horizontal plane as a horizontal, so you need to make arrangement like you can rotate here by X, Y, Z, and you can change the degrees, and you can make a correction of positioning. Okay, so in our case is like this. So once you click left hand side mouse button, so that will be set onto your assembly. Okay, so you can see here in the tree your part, and that is, if you open this black triangle, so you can see that it has front, top, and right. It means included in this part. And in upper position, you can see on your tree there is front plane, top plane, right plane, and origin. Those are related to your assembly. Okay, so that is assembly's front plane, top plane, right plane, and origin. And what's inside this part is front plane, top plane, right planes are those planes are related to your part. Okay, so now we have to make coincidence, or we have to make together this top part with assembly top part, and front plane with front plane. So this is a 0, so we have to the coordinates of this part match with assembly 0. Okay, have to make this one. So now if you want to change the position of your part by clicking left hand side mouse button and moving your mouse button, it doesn't move. So how to make move this one? So once you click right hand side of the mouse, you can see that in the list if you see the float word or command the float option, so that means your part is fixed. Okay, so once you are able to click the float, so that will be a float. Now you can simply click left mouse button, and then you can change the position. You are able to change the position. And if you click right hand side again, you will see the fix. If you click fix, so that will be fixed, and then so you cannot move. So to move, you have to click right hand side again and click float, so now you can change it. Okay, so in the floating position, so we have to match the front plane with front plane, top plane with top plane, and right plane with right plane. How to make this one? Just you can use a mate or command from the command manager. So click mate function, and you can see here the mate selections. In here you can open assembly and the parts from plane. Choose the parts from plane here and choose assemblies from plane. So now those are coincident with each other, and every time you have to click OK. So this sign, okay, OK sign. This sign also same thing. So what we did, we made it coincidency with front plane of the part and front plane of the assembly. So those things are included inside a mate. Once you click this, so you will see now inside a mate list, so the coincidency. Okay, so you can if you want to change something, you can delete this one by clicking right hand side mouse button and click delete. You can delete it and you can make change whatever what you do. So every part initially it has 6 degrees of freedoms. So those are the movement along x-axis, y-axis, z-axis, and rotation of along x-axis. Those are theta x, that's the pitch, and the rotation along y is u, theta y, and rotation along z is theta z. So initially every part has this 6 degree of freedoms. Okay, so in our case, after after making coincidences, 3 coincidences of the part top plane, front plane, right planes with assemblies front plane, top plane, and right plane. So our part cannot move anymore. So after clicking fix, also is fixed and cannot move, cannot rotate it along x-axis, y-axis, z-axis, and cannot move x, y, z directions also. So on fixed part, we can add many other parts. Okay? So one by one, we have to reduce degrees of freedoms of each part. So to put the new components, we have to click at the top of the command list. So insert component, and here in the browse, you can open the next components. Okay, so we need a 4 like this parts and 4 like this parts and 1 like this shaft. Okay, so we can insert one shaft here. So we simply put here and click one more time, insert components, rows, one like this component, and you can click Ctrl button and you can copy it 4 times, insert component, open this, hinge, so 1, 2, 3, so 3 times copied and 1 it's its own part. So 4 like this part and 4 like this brackets and 1 base and 1 shaft in it. So, and you can move this one by clicking left hand side mouse button with holding left mouse button, and you can move it. Okay, so all are can be moved, but first one is fixed. So if you click right hand side, you can see the fixes appearing. So that means those all are the float. except this one. This one is fixed, so you can see floats common here in the list. So we have to put this one inside this attribute correctly. So we can use a mate option, mate common. So you can select face of this, outer face of the cylinder, and top side of top plane of this one, or behind this, the bottom face of this one. Okay? So the faces, we are working with faces, and in some cases we can work with edges. Okay? So we have to select the wall of this, the cylinder, outer face. You see, face one belongs to the shop, and inside of this hole, okay? Inside of this, not the edge, just inside the hole. So two faces are selected. You can see the cylinder is come in inside this. So insert it to the inside the hole. You have to click OK. Okay? And to see, you can click OK. So you can see the concentricity is on. The concentricity is needed along between these two parts. So now we can move to the y direction, and also we can rotate along the y axis, but we cannot move x direction and z direction, and also we cannot rotate along x and z directions. Only 2 degrees of freedom exist now. Okay, left. So we can make other mates. So we can set the other mating, saying that the height position we can locate how to make it. So click mate, and you can see the mating faces. Like we have to select a face of the bottom face of the cylinder and bottom face of the base. So you see that the coincidency is on, but we can make a coincidency like this 0 position. Okay, same position, same plane line lies, but in our case we can set distance. So distance, if you make this one is upper, so you can write the value distances here, or you can change the distance in different side by clicking flip mate alignment. So if you click this one, so it will be flipped. So the cylinder will be in the bottom side. And another thing is, here you can set the minus value. For example, if you set here 10, if you insert 10 millimeter, so that is in the bottom, you see, set up 20 millimeter to see this. 20 millimeter is done from the bottom face of the base, or if you click this flip dimension, so that will be in the upper position. You have to click OK. So you can see now in the list, inside of mates, the 3 planes are mated in concentricity and distance. So by clicking this one, you can see with color identification. Okay. So this one is fixed, so cylinder is fixed, so now you cannot move along y axis, but you can rotate it. Just you can remain the rotation freedom. Okay, so let's do other assembling things, like okay, so this part inside of this one should be outside of this face. Okay, so concentricity is on. Click OK. So you can move like this way, and the distance of between this face and also this face, you can set the distance 120. Click OK 2 times. So now it's done. concentricity and distance. So the only thing is this rotation of along y-axis is left, so we have to set an angle between this face and this face. So now is those are parallel, but in our case we need to set some angle. It is 10 degree, and it should be to our side. You can flip, or you can set that like this. So that is different side. This is different side. So that is from far from us. This is to near us. So click OK. So 10 degree. So now we cannot rotate and we cannot move along y axis also. So now we have to put another part. So inner this face should be concentric with this one. Click OK. But we can move like this. Axis Z. So we can do it like this clear. So this face, that face, should be constant with that one. Click OK. So we only move like this. We can rotate like this way. So to set the angle, select this face and that face, and click angle making button. So here this one should be 160 degree. Click OK. So select this part outer side, this part outer side, and click inside of this part. Click OK. So we can move like this. So this face and that face can set as a constant. Click OK. So inner part cylinder of this outer face of this. Click OK. This shape is face and that face. Click OK. This face, that face. Between them, this angle should be 150. 150. Enter. So that should be near to us. So this kind of position. Click OK. Outer face of hinge and inner face of this. Click OK. This not the edge, just can select the face in between two circles. So this face, that face. Constancy. Click OK. Inner face of the cylinder. Inner face of the cylinder. Okay. This face. That face. Okay. This face and that face. Angle 140. 140. So it should be to the upper position. So now this cylinder and that cylinder. Okay. That coil and that face. Okay. So this hinges we don't need. Click OK. So you have to delete this. Just right click, select with right click and delete it. Click yes. So now our part is assembled. You can see, you can check this. So you can zoom in and zoom out by using a mouse wheel, rotation of wheel. You can zoom in and zoom out. And by clicking of this wheel and move the mouse, you can rotate itself, the part itself, assembly itself. By clicking a space button and clicking this button, you can set isometric view, or you can simply click Control 7. Okay, so after completion as an assembly, you can make an exploded view in order to see how the components are assembled or dismounted. So click exploded view, and we are going to dismount this one, disassemble this one. So we can click the hinges of this assembly, and here you can see the arrows. On the turn to the arrows, we can dismount, but in this way we cannot dismount because Z direction is not proper direction. So that's why we have to click the blue button right hand side of the mouse, and in the list we can make a line to command. So a line to command, and we can select the edge of the cylinder. So then the arrows will be the perpendicular position of to the cylinder or circle. So then we can move like this direction, so Z direction. So we can take out this component from the assembly. So then here you can see on the left hand side the steps of we did already. So first step is done. So here you can see the ellipse, or that is a that shows the rotation possible. So we can rotate. So here the degrees are shown. So the part can be rotated like this. So another click makes you the other step, the movement possible for next step, and we can use a Z. Again, one more time, left click of the mouse and then rotate it, and one more. So you can see here the many steps are generating. One more click and X direction. So there are 4 steps to dismount this one. So then next click for the this part, and then we can move, or we can check that for the movement. So Z direction is possible to move without any problem. Okay. So to dismount this one, again we have to open first the hinge. So select the hinge bar, click the button, the right hand side of the mouse, click align to, then select a circle or circle component of the this part, and then select Z direction by the moving of your mouse by clicking left hand mouse button. One more time click, and then rotate it. One more time click Z direction. So now we can select this, click align to, and you can select an edge of this. And align to. Now we can move by Z direction by clicking and holding the left button of the mouse. So here the steps are generating again. More click and hinge. So right hand side mouse button. Align to the circle on the hinge. Okay, so you can use a Z direction. Let's check this. Okay, so that's correct. Not correct, because Z direction is not properly aligned with cylinder. So let's make again a line to, and then select a circle on the hinge. Line to, so now we can move by clicking left hand mouse button to the Z direction to this side. Select this component, then move to Y direction like this, Y direction again, one more time click, then we can rotate like this way, one more time click, and opposite way of the Z direction. The final one, the click to the cylinder component, move by Y direction, one more time click with left hand mouse button to create new step, and then move it around this circle, and then click one more time, rotate like this, and one more time clicking my left hand mouse button, and move it to this direction. So now you can see 18 steps are made, and click OK. So here if you see the third one in configuration manager, you can see the assembly default is shown, and if you open the black triangle, so you can see the exploded view 1. So inside you can see all steps we created, and if you click right hand side button of the mouse when you select exploded view 1, and if you right hand side bottom mouse, you can see this kind of list. In the list you can see the collapse command, so click collapse. So when you click collapse, so that will show you the assembly view, and if you click one more time you will see the explode word, explode label. So if you click this command, so that will be exploded. So every time when you want to see that is exploded view, so you can make like this thing. So another thing is you can animate how to make the explosion or assembly. So click next command after the explode, animate explode. You can see the animation which you did by step by step. So there are three modes. The first one is a normal mode, that shows from the starting up to the end. After the end, that will stop it. After the end, that will stop until you click the play button. The second mode is loop. So once you click this one, it will play to you how to explode, and then the explosion starts from the beginning until you stop it. It starts again until the end, and then starts again and again. The third one is reciprocation. So once you click this one, that will explode and then assembly one by one. So in this mode you can see the way to assembly. So the sequence of the assembling, where to assembling, how to explode it, how to dismount this one, and how to assemble again. So in this mode you can see the slow play and 2 times fast play. In here you can save your animation in AVI format, and so your animation will be saved on your local drive. So here you can see the different aspect ratios, and you can see the frames per second. If you increase the frames per second, so you can get good quality video, but the volume will be bigger. But if you make a small number of frames per second, you can get small files, but animation quality will be not so bad. Using explode line sketch, we might create the lines for documentations. With animation, we can see the explosion or assembling sequence is using video information, but in here we can generate the lines which to show the assembling sequence for documentation. For example, items to connect. I select this one and that one, so the line will be generated. So this line shows that this component should be assembled in here. And to this one, this should go here, so I can remove this thing. So this one is moved here. We can modify the line. So click OK. And so this one, enter here. So you can alternate PS, change the position of this by clicking these arrows. This way is more understandable. This okay. Select this part. It's going to inside here. Okay. So this one is going here. So make this okay. This part goes here. Let's make this okay. So this shows assembly sequence in case of if you want to generate documentation. Okay.